Last time we left off with a little bit left to do, one set of examples left to do in section 1.6. So we're going to flip over to those quadratic type problems. So the reason that it's sort of titled this way, or that I've titled it this way, is because the methods that we use are quite similar to quadratic equations. But what you'll notice in these is that none of them are actually quadratic equations. This first one, for example, has a power of 4. That's not quadratic. There's a name for it. It's actually quartic. We don't use it very frequently, but it's not quadratic. And yet it still is going to solve in a very similar way to what we did when we had quadratic. So let's take a look at that. If I were working with this and it were a quadratic equation and I had the 3 terms, one of my options, especially because there's a 1 here at the beginning, would be to use trial and error to factor, right? Yeah. So we can write this and we're going to use trial and error. The difference is that instead of putting an x and an x here, I need them both to say x squared. Because x squared times x squared is x to the 4th. Okay? Not only that, but it matches the x squareds in the middle as well. Then what I need to do is look at the signs, just like I did before. Hey, look, there's a positive at the end, so my signs have to match. There's a negative in the middle, which means my signs are both negative. Lastly, I need 2 numbers that multiply to 10 but add to -7. What are they? 2 and 5, you bet. Okay, and it's equal to 0. And again, just like when we would do with quadratic equations, is we would take each piece and set it equal to 0. Now you'll notice, as we do this, each of these still has an x squared in it, right? So it's kind of like what you were doing in 1.5 again. We're going to use the square root principle. We're going to move the value to the other side, and we're going to take a square root. So I'm going to add my 2. So x squared is equal to 2. I'm going to add my 5. So x squared is equal to 5. And then we're going to take a square root of both sides. So when we take a square root, we put a plus or minus on. And there's no way to simplify square root of 2, which is actually a good thing because it means we have less work to do. And over here, same thing, plus or minus, and I have square root of 5. And those are my 4 answers because it's a power of 4 problem. It doesn't always give me the exponent, but it could, and this one did. So do you see why I call them quadratic type equations? We really didn't do anything different than we did before, except for that very first step where we wrote down x squared in the location I normally write x, and the very last step where I had to take a square root. Everything else was the same. Now this isn't the only one that's a quadratic type equation. This is an example of another one that is. Now, in some sense, it's really tempting to say, okay, well, I could square it out. I could recollect like terms. I could, then refactor and all of that. And you could. At least you possibly could. It'd be a lot of work. So instead, what I'd like for you to recognize is that we have something squared plus, or minus in this case, 2 times that same something. The parts that I've highlighted in yellow match, right? So I'd like to propose a way to make it look a little bit cleaner through our work, and we will reintroduce that u squared plus 2u at the end. I'd like for us to just give this another name, and we're just going to call it x, because we get to pick a letter, and x is a good one. And what I've highlighted in yellow is going to be exactly what x is equal to, u squared plus 2u. I'm just making a replacement so that it looks cleaner. That's really all I'm doing. So over here in the problem then, now I have x squared minus 2x minus 3 equals 0. That's quadratic, right? Absolutely it is. So we just employ whatever quadratic method we want to use to solve it, factoring if and when we would like to do so, if that's possible, quadratic formula if we choose, completing the square, whatever we would want to do after that. A lot of times factoring works, so we're going to give it a try, especially again because there's a coefficient of 1. We can use trial and error. So if we attempt to factor, we find that x in there and x here for the x squared. The end, the signs this time are negative, so they're different. I need two numbers that multiply to the 3, but then add to -2. Right. -3 and +1, you're right. Okay, so far so good. Now, it's kind of up to you. If you want to set these equal to 0 and solve, at this point you could. But eventually we have to reintroduce the fact that we don't really have x in our problem. We have u squared plus 2u. So I'm going to do that right now, just because I have to do it either now or later anyway, and it's cleaned up to the point where I think I can handle it at this point. I've got the factoring part done. So I'm going to put these in as u squared plus 2u, now minus 3, and u squared plus 2u plus 1. So notice all I did is I replaced x with what x is equal to in both locations. Is that all right? Excellent. And then we can actually do that setting each part equal to 0 that I didn't do before. And the reason I didn't do it before is because I recognized, sort of thinking about where I was headed, that these are not going to actually be helpful to have the 3 move to the other side or the 1 move to the other side, which is what I would do if I solved for x. So I have u squared plus 2u plus 1 equals 0. So lo and behold, at the end of the problem, what I actually have is I have 2 more equations that are both quadratic, right? So I'll solve 2 more quadratic equations. Again, if factoring works, it's often the nicest approach, and trial and error is an option that's accessible to us this time because we have a 1 in front of the u squared. So I've got u and I've got u. This is almost just like the first one I started with. I have a -3 at the end, so I have a negative and a positive. But this time I want it to be a positive 2u, whereas the last time I wanted it to be a negative 2x. So I'm going to have a -1 and a positive 3. I'll come back to that in a moment. Let's factor the other one. Okay, again, u and u. And I simply have no choices. It's got to give me a 1 at the end. So they got to be a 1 and a 1. And the signs have to match because it's a positive at the end. And the positive in the middle tells me that the signs are both positive. And sure enough, that will give me the 2u in the middle. So that is the correct factoring for it. So the last thing then is to set all 4 of these equal to 0 and solve them. I'm kind of low. Well, you guys are high enough. I think we can work it out. U minus 1 equals 0. U plus 3 equals 0. I technically have u plus 1 equals 0 and u plus 1 equals 0. Obviously, those last two give me the same answer, so if you just wanted to put one of them down, that would be fine. And if I shift each of the values to the other side, the first one gives me u equal 1. If I shift my -3 to the other side, u is equal to -3. And if I subtract my 1 to the other side, u is equal to -1. Or if you want, you could write u equals and just list all 3 values. That would be fine too, and with commas between them. Now we only have 3 solutions to this. That's happening because that fourth one, it just mirrors another one we already had, right? But technically there really are 4 solutions to this. And that seems like it should make sense, and it does, because if you were to take u squared and square it, you'd have u to the 4th. So this is really a power 4 problem, much like this one really was if we had multiplied it all out. So multiplying things out and making them become sort of more full looking, right, like bigger looking, is usually not our best approach. If our goal is to solve things, we want to break them down into smaller pieces and set things equal to 0. So that's why we like this approach on this one instead of distributing it all out. Not because they're both possible solutions. This one's just an easier approach. Okay, and that's the last one for this section. So those are the quadratic type equations that you're going to be looking at, with some variations, of course. So we're done with section 1.6.